Good day, Sir Jace Matioy. Today's discussion is about how to solve for the energy released in joules of earthquake. The earthquake that I chose is the most powerful one in history, which is the Valdivian earthquake. When did it happen? It happened on May 22, 1960. Where was the epicenter of this earthquake? The epicenter of this megatrust earthquake was near Lomaco. What was the magnitude? The magnitude of the earthquake was 9.4. Was it destructive? Yes, it was destructive. Using the formula of the Ritcher Scale, how can you solve the energy released in joules? What will be the derived formula? I can solve the energy released in joules by using the Ritcher Scale. So the formula we're using to get the joules on the earthquake is the Ritcher Scale. The formula of the Ritcher Scale is R equals 2/3 to the logarithmic of the ratio of E to the power of 4.40. And our first step is to get rid of the fraction. We must transpose 3 to the other side and divide both sides by 2. So when we divide this by 2, it gets cancelled. When we divide this by 2, it gets 3/2 equals R equals log to the ratio of E to the power over to the 10 to the power of 4.4. The second step is to expand the logarithmic expression. Here we use the second law of logarithm, which is log to the u or v with the base of b is equals to log u logarithmic of u to the base of b minus logarithmic of v to the base of b. So when that happens, we get the outcome of 3/2 r equals logarithmic e minus the logarithmic 10 to the power of 4.4. Step, we must transpose. So logarithmic e transposes to the left so that we can isolate 3/2 in r and logarithmic 10 to the power of 4.40. So in that outcome, we get logarithmic e equals 3/2 r plus logarithmic 10 to the power of 4.40. So the r, we must substitute it for the magnitude of the earthquake, which is 9.4. So 3/2 times 9.4 is equals to 14.1 plus the logarithmic of 10 to the power 4.40. The logarithmic of 10 to the power 4.40 is 4.4. We add these two, we get the outcome of 18.5. Logarithmic e equals 18.5. The last step, solve for e. Here, we use the second property of logarithmic, which is log to the base, log with logarithmic of b to the power of x with the base of b equals x. So logarithmic of b with the base of b to the power of x. Since we don't have b here, we can assume that the base is 10 in the Ritcher scale. So as you can see, logarithmic 10 the power of 18.5, which is the x, with a base of b 10. So when we solve through this, logarithmic 10 to the base of 10 to the power of 18.5 is equals to e equals 18.5. How can we sure that 18.5 is the right answer? Now we must double check. Here we have r, this. We substitute it for 9.4 equals 2/3 to the logarithmic of 10. The e is now substituted. E is equals to logarithmic 10 to the base of 10 to the power of 18.5. So logarithmic 10, 18.5 over 10, 4.40. 4 to the power of 4.40. We solve for that. We get the answer of 9.4 equals 2/3 to the logarithmic of 10 to the power of 14.1. So what is the logarithmic of logarithmic 10 to the power of 14.1? The answer is 14.1. When we solve that, 2/3 times 14.1 is equal to 9.4. Therefore, r 9.4 is equals to 9, e equals to 9.4. So it is the same. Therefore, the amount of energy released by the earthquake is 10 to the power of 18.5 joules. That is all. Thank you.